So here we have Randal Koene, and Randal works at Halcyon Molecular, as we've discussed in previous videos, and is also working on initiative substrate-independent minds, and we want to just start with talking about the idea of metacognition, which is an idea that people can think about thinking and recursive thought. So so do you have much of a background in? I think metacognition is a psychology term, but I'm trying to apply it more to the engineering and the possibilities of how you sort of implement this into an artificial intelligence, making it a general thinker and being able to recursively self.
Oh, I can see that. Yeah. So, I mean, you mentioned it as a psychological term, or this recursive thought, which is a bit vague to me. I don't quite know what to think of that. But when I think of metacognition, so knowledge of how we think, it seems to me, from a very concrete engineering point of view, that there's a ton that you could do just with that concept. So, for example, if you know something about how our thinking happens, if you understand a little bit about it, then you could use that to regulate your thinking or improve it in some manner, right?
That's right.
It allows you to take a look at the thought process that's going on, and then either upregulate something or downregulate something. Say that, oh, this is going into a dead end, quit that, start a new cycle, maybe a new seed of thought. So just in a very general sense, there should be a ton of things you can do. And then even just just from the point of research, it's nice to be able to think about understanding more about how we think. But I think as a practical application, that's the most interesting aspect.
Sure. So, I mean, meta-memory is like knowing about your memory and giving you a place in sort of a time period. People have suggested that humans are the only ones with sort of recursive thinking, in a sense that we can embed an idea into itself. I'm not sure how much evidence they have that some animals don't, because it's very hard to communicate with them. But I guess there's some sort of people out there who believe that most, or at least all, animals don't, and that's what divides us between us and them. So, but have you ever came across Noam Chomsky's idea that that thought is fundamentally linguistic, and that we need language before we can have thoughts? And the idea of recursive thinking and how it's thought to have evolved is purely based on language, but I for one disagree with that. But
I've come across it, and I also, I guess, I don't agree fully, even though I understand what he means. And I don't agree fully, mostly because of the definitions involved. Just the fact that you have to think, first of all, about what it is you're talking about when you say thinking. Thinking is such a broad term, but it seems like when Noam Chomsky is talking about it, he means something more narrow. He means specifically the kind of thinking where something like this recursive metacognitive process is possible. He means something where you're doing a very specific type of thing, because when you're more general about it, like if you ask a neuroscientist what thinking is, they just say, well, it's the processes of the brain. So it's any time when you've got information coming in and it gets converted somehow, it gets transformed, and then it gets sent somewhere else. And of course, even the lowest animal that has any set of neurons and does some sort of transformation like that carries out those processes in some way. So then you've got thinking going on, and machines do so too when we have machines that process information. So you could say from that point of view, there's thinking going on in tons of places where there is not this concept of language in the way that we think of it, although if you just mean symbol manipulation, and if you then take patterns and associate symbols with them and say, okay, this is how I'm going to represent what's going on in that system, well, then you would just have to say, okay, Noam Chomsky's right, because it's all language. But again, that's just a matter of toying with definitions.
Yeah.
But I'm hard pressed to think that it's I guess thinking is maybe, to me, doesn't seem as uniquely something that is very language oriented in terms of there being a grammar, and there being all these
The
rules
universal
that you
grammar
find in
idea,
these
yeah.
formal language processes that of course linguists like Noam Chomsky talk about. But I do agree that that the sort of recursive thinking that we're doing, that requires the ability to carry out these formal processes, however they're implemented, even if they're not implemented the way that they represent them in linguistics. Clearly, it means that you need to be able to build representations, so models, in other words, symbols, of something, and use those within the context of your thinking, so that you end up thinking about thinking or making statements that refer to processes of thought or abstract concepts. So sure, that's really important for what we consider human intelligence. Although I think there's so much of the definition stuff in this Noam Chomsky stuff. What are you talking about? It's a bit hazy to me. Yeah.
So, well, the question is, did language adapt to the brain, or did the brain adapt to language? I mean, in my understanding, language, the complex language that we have, that we communicate, that we all agree on is a medium for sharing ideas, is a tool that we've developed, or that the organism that we evolved from developed over time. And so I think the idea of language, or the usefulness of it, actually came out of the brain, not out of language itself. So, and I think we've also developed tools, physical tools, hand axes, bows and arrows and whatnot. We probably evolved in accordance with the tools that we were creating, like a feedback cycle between the language and the tools.
You're right. You're already stating exactly what I think as well, which is that it's both, right? Because we can say for a fact that, of course, thinking and the brain precedes language in what we call language, because brains already existed, and existed in species that did not speak, didn't have language the way we do. So clearly, language came out of that. It's not the precursor. But at the same time, if you have a tool that really works and that has advantages, then you're going to have evolution selecting for it. So then you're going to have updates and changes in how the brain works based on what you do with language. The same as with any other tool. I mean, why do animals that have certain features in their bodies, like particular sets of teeth or something like that, why do they continue to develop to the point where those are very, very species specific and very particular? Because, well, it turned out that was useful in some way, and so it kept on evolving further into the perfection of that tool. So you're going to see that,
We didn't evolve. We didn't rise to prominence in the human species by being very good at biting or digging holes, or using our arms to flap about and fly. We evolved we evolved our intelligence. That's what gave us the advantage in our niche, which turned into a pretty big niche as we see it now.
Right.
So the idea of recursive thought has been argued as what defines us as humans, and I can see there's an argument for that. It doesn't necessarily imply it may imply, but it doesn't necessarily equal the idea that no other animals have any form of recursive thought.
Right. I wouldn't say that there's proof of that. No. I mean, how do you prove that, right?
That's right.
That they don't have recursive thought.
Yeah. So during the Pleistocene sort of era, when we had to adapt to some harsh conditions, that was put forward as a time when we may have first developed the first seeds of the human form of recursive thinking that was able that sort of gave us the advantage when we could adapt to surroundings and adapt to the environment, but also develop a certain level of societal communication that enabled us to work together in advanced ways to survive. That was put forward. I forget the guy's name. I'm trying to look for it. I've got it written down somewhere. Yeah. So
Okay.
I'm thinking though that often, like when AI is developed, they give it an environment to evolve in.
Yeah.
But how do they regulate the environment very much? I'm not sure.
Most of these AI things are extraordinarily simple lab environments. I mean, by lab environment, I don't even mean a real lab. I just mean, some square.
Yeah. Like the
On
game
a
of
screen
life.
or something like that.
Yeah.
It's nothing really.
So I'd like to see if there are any existing, or how developed any existing approaches to developing AI which incorporated a regulating environment, one which went through various cycles of extremes to help develop an organism that was more general in its way of thinking. You see, we don't know how to develop artificial general intelligence, but we know that it did evolve in us to a degree. We have a level of AI, or artificial general intelligence. But how did that come about? I mean, it came about because we were lucky. Okay, there's probably some luck involved, but also we were subjected to environmental conditions which favoured a more general way of looking at the world rather than complete sort of narrow ways, or just relying on intuition.
It looks like we have to survive certain, I guess, crises or challenges and make our way through various different environmental challenges like ecological niches, ice ages, and then warmer times in different places. Sort of be adaptable to some degree and move about. I mean, we had a nomadic lifestyle for a long time. So I guess that probably played a role. And I would agree that this is also something that can be explored as a useful tool in developing AI. I was wondering if you knew about the company DeepMind.
No, I don't know anything about DeepMind.
It's I guess, it is an AGI company, an artificial general intelligence company. I'm just quickly typing in to see if I can find their website because it might be useful for you to see. And where is this thing? I can't immediately find their website, but it's run by. Now why am I having this problem? See, human memory has this issue, at least in my case, with remembering names. So even though I know exactly who I'm thinking about, and I've spoken to him a gazillion times, at this moment I can't recall the name of the person who's running DeepMind. But he used to be a national chess champion, and then he became rather wealthy, well, at least somewhat wealthy enough to do his own thing by developing a game company and selling it. And then he turned his sights on neuroscience and on AI, and he got some seed funding from Founders Fund to work on that in the UK. So they're working in the UK. They've got this company called DeepMind, and they're developing an AI approach where basically, I guess, they're relying a lot on his knowledge from gaming. So I don't know if that means that they're using a lot of what he's been putting into non-player characters, but I'm assuming that at the very least it means that they're developing some sort of evolution approach that has something to do with providing environments and providing tests and challenges to the AI. So in that sense, it sounds very similar to what you were just talking about.
Okay, interesting. Was he also a poker champion?
He might have been. I'm not sure, but he was also at several of these conferences like H Plus and Singularity Summit. I really can't understand why I can't recall his name right now. It doesn't make any sense.
That's all right. It'd be very interesting to see if we could sort of use some sort of Bayesian formula to look at history and look at what would have most likely been the actual types of events that would have favoured recursive or metacognition, recursive thinking, what types of what some examples of recursive thought that are some examples of environmental effects that would have been, in our history at least, conducive towards recursive thought. No, I don't think it's. I've made some assumptions like you have, but it'd be very interesting to pinpoint times and events and localities to sort of
specific things that
specific
have actually
things,
led
at
to
least,
the
you know,
development of recursive thought.
or
Is that what
general
I'm thinking?
thought, general thinking. Yeah.
Or general thinking in general, not just the recursive thought aspect.
Well,
Not
actually,
just
they're different. Really,
metacognition.
I'm getting them mixed up. I think animals can think generally, in a sense, to a degree. Like we know, dolphins and elephants can sort of think somewhat generally, but there's another layer and there's another subtlety to general thought compared to recursive thought, and that's the idea that we can talk about a concept in one way, and then we can talk about the very same concept in another way. We can embed that concept in itself to sort of give us the idea of like identity, for instance, like cognita ergo sum. I think that therefore I am. That's probably a prime example of recursive thought that isn't necessarily that is general thought, general cognition as well. Probably requires some form of general cognition, but general cognition alone wouldn't be enough for that, I don't think. Yeah.
What are you actually trying to ask?
So I mean, does self-reflection, does general cognition require self-reflection?
That's a really good question, because this actually gets down to one of the big questions that is asked often. If you had an artificial general intelligence, would it have to be conscious and self-aware? Because there's some aspect of this, that self-awareness requires self-reflection, or vice versa. So could you treat it as a tool, or would it have to be its own thing, its own entity? There's that sort of thing, right?
Yeah, that relates directly, I guess.
Yeah.
That's a question I've thought before, but for some reason I didn't connect
I'd be
them.
very interested to figure that out. If you think of artificial general intelligence as just something that you can come across by using one algorithm really well, which is one of the approaches that a lot of the German AI scientists seem to like to approach, like to take when they're looking for it. And I think I would classify Marcus Hutter as one of the people that works along those lines, looking at it as an algorithm problem.
Yes.
I'm not sure how successful that'll be, but I can imagine that you could probably solve a lot of useful problems that way. Only the temptation is then there to just call it machine learning, because it seems like it's just an algorithm.
Yeah.
Again,
But
definitions.
but
What is
the
not an
definition?
algorithm?
Yeah.
But
I think we're like
this whole
people
self-reflective thing, is that useful or necessary for general intelligence? There's even
I don't know if
That's
it's
really
necessary
debatable,
for it.
because there's even an argument to be made to say that being self-reflective, being aware of yourself, making a model of who you are and putting that inside of the whole problem would make you less general, because then you're basing everything on your own your own perspective on yourself. Subjectivity makes you less general. So maybe really general artificial intelligence would be one without the self-reflectiveness, even though somehow intuitively it feels as if one couldn't create what we consider general intelligence without it. And I think that's because we don't have a really good definition of what artificial general intelligence is. I've debated this with Ben Goertzel and with Moshe Lux and others many, many times. What is artificial general intelligence? What is it that you actually look for? What is it that the conference is about, and the book and the journal series? And what is it all about? Because some people seem to mean something that is artificial human intelligence, and possibly a little smarter or a little better than we are, but basically like us.
Yeah.
And other people really seem to mean something that is mathematically, rigorously general. So then if you talk to Marcus Hutter, he'll probably be pointing at that. And those seem to be two different things, because if you want something to behave, look like, act, be recognizably sort of like us, kind of an artificial human intelligence, then yeah, it probably needs to be self-aware, it probably needs to have a model of self and recursive thinking and all that kind of stuff. And it may not be general in the mathematical sense of generality. It may just be broadly applicable, kind of like a lot of our thinking is. I think this is a debate that needs to be fought internally in the AGI camp first to figure out, are these actually two different directions you're going in? Are these two different goals people are going after?
Ben, I've spoken to Ben a lot about this. What is general intelligence? And I think he doesn't believe that general intelligence is what you get in a human. Humans have a level of general intelligence, like that we're good at maybe explaining things in one way and another, and that our self-reflectivity, our recursive intelligence, helps us be more general than we would be if we didn't. I think he has more of a computational sort of approach. He doesn't believe that the only general intelligences out there must be self-aware. After all, he's a panpsychist. So, but he does believe that there is consciousness sort of embedded in physics somewhere.
I understand that this is what Ben thinks, which is probably why we have this vagueness at AGI in general, because that's really Ben. It's a reflection of Ben. Okay. Ben believes that there can be many roots to artificial general intelligence, and that it may be something very different than human, and that there's something bigger, something more important about general intelligence, something that we need to grasp, that is out there. And at the same time, when you look at the approach that he's taking, when you look at the way he's going about it, it looks a lot like he's aiming for artificial human intelligence. OpenCog is sort of an approach at artificial human intelligence. Yeah. So his approach is definitely not the very algorithmic, detached, abstract version.
Sure.
And so I think the fact that this is unclear at AGI may reflect a bit about Ben, really. But at the same time, it doesn't mean that question isn't there. Are we supposed to go for the abstract algorithmic thing? Or are we supposed to go for the modeling human intelligence thing? Which one is the goal in that community? Yeah. I still don't quite see how introducing a self-perspective makes something more general. I think that might make things more specific, more subjective. So that's general.
Okay. Well, another question: do you think it'd be much different trying to upload a mind that didn't have recursive thought, the ability to embed ideas in the ideas themselves, compared to a mind that did have this ability? So a mind that wasn't couldn't metacognize or recursively think, compared to a mind that could. Would there be a difference in providing a framework for uploading the two different types of minds, if we can arbitrarily sort of separate them?
Well, I mean, the only kinds of minds I've looked at in terms of uploading are the ones that we have, which have this self-awareness and metacognitive aspect to them. Of course, what it really is a reverse engineering project, system identification project. And you can apply that to just about any technology. You could do reverse engineering of a computer chip and make another model of it and run it somewhere. So the process, the way of doing what we call uploading, you can probably apply to any type of mind. Though that's not usually what we're targeting.
Yeah, I agree. It all comes down to patterns, as far as I'm concerned. There's nothing special about our mind that exists outside the realm of patterns. It's all physics. Physics is patterns. There may be a difference between a mind or like a completely unconscious mind that can operate in the world and have no identity but be able to survive and supposedly live in the world, compared to it all comes down to a different configuration maybe, but it's just patterns. If you can reverse engineer the pattern, then surely you'll be able to recreate that pattern into different substrates.
If you can identify the pattern, that's what I mean. If you can identify the pattern, then you can put the pattern somewhere.
Sure.
That's basically what the reverse engineering is, right? It's to find the patterns. Yeah.
So when do you think we'll need more technology than we have today in order to find these patterns? Does substrate-independent minds require more development in certain areas of technologies, or more innovations and breakthroughs in how we reverse engineer these patterns, or how we identify these mind patterns?
You mean, you're talking about substrate-independent minds now, right? You're not talking about metacognition.
Yes, that's
right now.
right.
You're just asking about, are there any breakthroughs that are necessary to be able to have the tools to do an upload of the patterns that you're looking for to some of the substrate?
Yeah.
Well, in terms of, I guess it depends on what you call a breakthrough. I don't think it requires a scientific breakthrough. It doesn't require a new understanding of what to look for. It requires tools that can do it large scale, that can do a lot of it. If you take any particular target in the brain right now and you ask a neuroscientist to measure a signal or to identify how that neuron is connected with others, then the neuroscientist has some tools available to do just that, and we can do it. But if you ask the same neuroscientist to please do this for 1 million neurons, then he'll shake his head and say that's impossible, we just don't have the tools. So that's where the work has to be done. It's an engineering project, really, but not an easy engineering project. It's a difficult engineering project. How do you make something like this work on a scale where you can capture the characteristic activity of 86 billion neurons and also grasp all their connections among one another? The connection thing, some tools exist. You know about the whole slicing and dicing method there. But on the other hand, for that functional stuff, that's really the place where there's a key area that needs development. And I guess you could call that a breakthrough. If you have a tool like that, that's a breakthrough, because then suddenly it opens so many doors and you can do so many things that have nothing to do with uploading even. Just from the point of view of neuroscience research, you'd have many options. And from the point of view of brain-computer interfaces, you'd suddenly have so many new options. So that's a tool to go for, yeah.
Yeah, sometimes I bandy about the term innovation or breakthrough, and I do realise that it sometimes can mean a complete change in the way we think about something, or a new idea about how we think about something. But often it's more subtle. It could be just trafficking of the direction of attention into a certain area and building up the framework there. But that area does have a framework, or the seeds of it, and has been thought about before. One of my friends at Melbourne University has been working on how the brain sort of primes action potentials with electromagnetic sort of impulses, the pulses inside the head, and he calls it ephapsis. Are you aware of what?
Sorry, I'm actually having trouble hearing you because the rushing sound is back with a vengeance.
Sorry, yeah. We're in a wind tunnel, maybe. Is it? He defines a term as ephapsis. Yeah. Have you heard of ephapsis before, or anything that relates to it?
I have. The word sounds familiar, but I presently can't recall what it means.
Okay. Ephapsis. So I think it's about the electromagnetic properties, or the electromagnetic signals that travel throughout the brain much faster than action potentials do, but seem to prime parts of the brain that somehow prepare it for an actual action potential to do something.
Oh, that seems like it's more about modulation, because the subthreshold activity, that's just voltage changes, and then of course you can say they travel fast by saying that this wave front is getting somewhere more quickly than a spike would, just because you've got a change of voltage. So yeah, that would put neurons in a mode where they're more likely to spike or less likely to spike and things like that. Yeah, that happens.
Yeah, so the passage of neural impulse from one nerve fiber axion or dendrite to another through the membranes. The mechanism may be a factor in epileptic seizures. Yeah, to be honest, I don't know much
Well,
about it.
absolutely. Modulation, sure, that can be a factor in epileptic seizures because if you're making the neurons more likely to spike, then you can have large quantities of neurons spiking at the same time, hence you have an epileptic seizure. So there's nothing wrong with that statement. It's probably correct. But I didn't remember that term was that. Yeah.
Okay, well, perhaps I should have sent you something about it before. But yeah, it's an interesting take. So he believes that it has something to do with generality in in the way that we think, and that it may be required for general intelligence. And it's one of those things that not many people have sort of spent much attention.
But if it is what I'm suggesting, which is that it is a process that tunes up or tunes down certain areas. Therefore, it's like an attention process. It's like a mode process. It can set areas of the brain into a retrieving mode versus an encoding mode. It can make them likely to spike more frequently if you're active and you need to recall a sequence. It can focus attention on one area of your sensory input rather than others. That's the sort of thing that modulation is for. And if that's what he's referring to, which is, in fact, an electrical activity that spreads throughout the brain separately from spiking and in some sense you could say faster. So it kind of seems to be what he's saying. If that's true, then yes, that seems like the sort of thing you would need for artificial general intelligence or artificial intelligence that has to be able to switch between different modes of operation or do different things. But it doesn't seem like a very complicated thing to implement. In fact, it's probably the easiest thing to do because you can just, in an artificial version of that, say, okay, now we're in mode 1, now we're in mode 2, use function A or use function B. It seems really simple, actually.
I think what he's saying is that there are laws of electromagnetism that that if we were to simulate might be quite difficult. He's saying that we should take a biological approach and create biological hardware, biologically inspired hardware, so that we'll be able to mimic or replicate the way electromagnetism applies to
this is where I really disagree, because I think that so from a system identification point of view, reverse engineering the brain, it's like, let's take the example of reverse engineering a computer chip. You can say that there are an enormous number of components in there that are making use of very complicated physical properties. Many of the transistors, actually pretty much all the transistors that we use in computer chips today, use quantum tunneling, for example, meaning that quantum mechanics and quantum mechanical effects are extremely important. And the same with all the electromagnetic stuff that goes on, that happens in the wires, that happens in the capacitors. They're all there. And so, yeah, it might be that this is way too complicated to model and simulate all of that and then do a software simulation of what's going on at the hardware level in the chip. But you know that that's not necessary, because in the end all you care about is the state in terms of ones and zeros in the computer chip and how they can be processed going from one place to another, which is totally doable in a digital simulation. And in fact, there are everyone who designs chips uses simulators to run their designs first before they build the chips, and they don't simulate the quantum mechanics, and they don't simulate the electromagnetic stuff. So taking that analogy and going to the brain, we wonder, what is it actually that conveys information? What is it that is important in terms of going from one neuron to another, or from having patterns talk to one another in the brain? And the important thing, this is sort of almost accepted now, is this currency of the brain, spike times. Spike times are very important. They are the currency of the brain because A, they're involved in determining when patterns cause memory formation or pruning of memories. So if spike times are very close together, then an association is strengthened, and therefore you are remembering something for the future. You're changing the system. And if they're farther apart, then you're not. Or if they're reversed, then you might be removing that connection or making it weaker. Again, you're changing the system. So spike timing is very important for that. Plus, spike timing is very important for something else that we often forget, which is it causes muscles to activate. And muscle activation means things like my being able to speak right now. And so it's the interaction with the universe around us, giving us I/O. So those things, spike timing, that's what it's really about. Now, it happens to run on systems that also rely on a whole bunch of biochemical processes that are indeed affected by and cause electromagnetic effects or fields and changes. But that's just like in that analogy there, where you can go too low in your attempt to do system identification or reverse engineering. Why do you need to model or represent all of that unless you have evidence that this produces effects in the system that could not be represented in a more simpler form, like what I was just saying before, where you're just switching the system between modes. Is the neuron now in a mode where it spikes automatically, keeps spiking, persistent spiking? Is it in a mode where it easily receives new information and updates its synapses, or not? These are the sorts of things that are actually affected by the kinds of signals that he's talking about. But those modes are like little switches that you could just turn on and off in your simulation, that you could turn off in this representation that you've made, or on. They don't require representation of how the electromagnetic wave is transported from one place to another, or things like that. It's too much detail, and it's detail that doesn't give you any extra information about how the patterns are talking to each other. That's my view, and I might be wrong, because maybe for some reason it'll turn out that there's some intricate thing there that you can only describe through going into very high level detail modeling or representing or reconstructing of how those electromagnetic properties are being transferred. But it just isn't obvious. It sounds just like the whole argument about the quantum mechanics, where you can say, yes, okay, quantum mechanics are involved in thinking or something like that, or everywhere in the universe, because everything's quantum mechanics, right?
Yeah.
But it doesn't necessarily mean that that's the best way to represent something. There's a place for Newtonian mechanics as well. Just saying this is how the cannonball flies, well, it's often a much better way of describing something if you're trying to send a rocket into orbit than to go into quantum mechanics. So, yeah, pick your level. There's a reason why.
Yeah, definitely. I mean, you'll get the chance to talk to him about it because he's going to be speaking at the Singularity Summit. Now, he's going to be doing experiments throughout this year, so he'll be able to either try and find proofs for his idea, or he'll contradict himself and say, it's not going to work out well. But also Marcus Hutter's going to be talking too, so we're having Marcus Hutter talk twice.
Do you have a list of the speakers yet?
I do have a partial list of the speakers, yeah, but I'll let you know. Yeah, I'll send it to you. So that's very interesting. I think some of the pop culture around biotech has been quite interesting recently. One of them being the spider goat. I mean, you've heard about the glow-in-the-dark kitten and the dog and puppies and all that. I don't think they're selling them as commodity sort of pets yet, but but I think it would be nice to have a glow-in-the-dark kitten. You'd never lose it. It'd be kind of cute. Be able to use to see in the dark.
Soon they'll be selling glow-in-the-dark children. That way you won't lose them either.
That's right. You want to know what your children are up to. You want to see what's going on in the dark. I'd like to be glow in the dark. I mean, I keep them bumping into things when it's dark.
I would like it if I could turn it on and off. Yeah, I should say.
I'd like to be able to turn that feature on and off. Morphological freedom. I think in the future we'll be able to do that. But
actually, there are animals that can do that, aren't there? There are plenty of animals living in the ocean that can turn on and off their luminescence.
Right. Yeah. But I think it'd be very hard to take some DNA from one particular animal along with the mechanism to turn it on and off and just put it in another completely unrelated.
Speaking of that, I know this may not be something you're really interested in during this talk, but it just happened to come up and I thought it's an interesting factoid. When we talk about uploading and substrate-independent minds, we spend an awful lot of time being very conservative and very careful to make sure that we, A, capture all the information that we need, and B, don't disturb the system too much, because we don't really want to change what's there. We want to capture what's there first before making any upgrades or anything like that. We just want to make sure we capture the real thing. Now, when I was thinking about that... Sorry?
You don't want to destroy the original before you upload it? Is that
You well, destroy the original. It's more about you don't want to mess with it too much. Like, let's say that you have a measurement method that involves doing something to the brain where the plastic brain itself changes in the process,
Yep, okay.
so that perhaps you're changing who the person is and their identity and everything in the process while you're working on it. Often we shy away from that because we're saying, no, we want to be as just basically observers and capturing information first before we do anything to it. And then I realized that when you think about the sort of things that we're willing to do today, when you look at the effects of chemical medication, gene therapy, even just surgery that people apply when patients have epilepsy or such, and they cut away entire regions of the brain and they just cut out pieces and stuff like that. When you just think about what we're willing to do today and how little discussion there is of, oh, well, will this process change that person's personal identity? Will they still be here? Is it going to be someone else? All that kind of thing. There's hardly any discussion at all. That's not really considered a very vital piece of medical, I guess, ethics or something. It's more about, does the patient stay alive? And
yeah, that's correct.
that sort of thing. So I've come to realize that actually in current medicine, we're willing to mess a lot with what's going on in the brain and in an individual's brain and their mind and their self without asking too many questions first. And I'm not saying that means we should have, the liberty to do whatever in an uploading procedure. I just thought it was an interesting contrast to see what's going on that side, on sort of the biology and medicine side, versus the really conservative thinking, very careful conservative thinking in terms of how to do uploading. That just occurred to me.
Well, first of all, we're going to do it with animals first, I believe. But we better be sure what animals we do it with. But
Yeah,
those questions aside, just as an addendum or a comment to what you were just saying, I think it'd be very interesting to approach uploading the human mind, uploading an actual human mind, and how it would be different. How it would be different in a couple of scenarios here. One is, okay, we have a brain that is not operational, it's plastinated, frozen, or just in a suspended form. So, well, can we upload a mind from that particular state without operation, without any sort of activity or mind activity going on? Just, can we upload a mind by reading the substrate that it existed on?
Yeah.
And the other thing is, if we do need to have a substrate independent mind, if we do need some sort of mind operation, and some sort of activity in order to reverse engineer it, then do we need a continuum of that activity, or is it just a snapshot?
Yeah, well, those are interesting things to explore. I'm actually tending towards the notion right now that to get a functioning mind, one that isn't full of errors and bugs and that you can computationally, tractably tune so that it works, you would need to get some functional data. But my feeling is that we can try to reduce the functional component as much as possible, meaning, worst case scenario, I would prefer to just be able to get a representative signal from every individual neuron so that you have an idea of what its characteristic action potential should look like. And that way, when you're tuning the system per neuron, you can tune it to see if you're getting what it should look like. That gives you an idea that things are tuned correctly, that you've picked the right model for the neuron. Maybe if we're able to do better parameter tuning and our computational capabilities there are large enough, then instead of doing measurements on a single neuron level, maybe you could do it for 100 neurons or 1,000 neurons. If that level is, if the number of neurons that you can just globally measure something from is big enough, then you may not even need to develop this technology that works from the inside, because then perhaps a scan like an MRI can provide you something on a voxel level that would be clear enough to give you an indication of what should be happening in this area. And then if in your model that you've made from the spatial reconstruction, you can produce the same kind of activity in that area when the other areas around it are producing their activity, then you can tune to that. So I'm not saying that's possible, I'm just saying if we had an enormous amount of computation available, and we could do parameter tuning, parameter optimization at a much more intense level, then the resolution at which we have to capture functional information goes down. We don't need as high a resolution. So this is why the system identification problem, it's really this trade-off between how much work do you do on the parameter tuning side and how much measurement do you need to do on the functional measurement side. And I do really want to avoid this problem where you have to get a long continuum of measurement, say over years or something like that. That is something that you'd need to do, for example, if you're avoiding spatial reconstruction altogether. If you're trying to determine what are the connections between all the neurons just from reading their activity, because then you need to find out how they correlate. So what are their mutual effects? What is activity in this neuron causing for activity over in this neuron here? So that you get some idea of what the connectivity may be, and even the indirect connectivity through other neurons. So yeah, that's where you need to start doing long continuous reads. Because basically then you're taking the entire brain and throwing it into one big black box where you're saying, I know nothing about the connectivity inside from a physical perspective. I've not looked at it.
Yeah, so you don't think you'd I mean, I'm just thinking that if the mind requires, if you need to sort of get some sort of like a continuum, maybe let's just say we could break it down, not 2 years, but like a 5 minutes of reading the brain, and therefore get like squillions of snapshots in that particular period of time. Would that make it more representative of what the mind, the original mind, if you were to upload something that both read the physical structure of the brain and all the spikes and all the functional operation of the brain, but also then had a recording, like a sample?
As validation, I would say, certainly, because if you had a recording of activity throughout, say, the last few hours or maybe days or even longer, then you could run your model through its paces by testing to see whether it can reproduce something like that recording.
I think it'd be very interesting if we could first, instead of just taking the brain and completely uploading it, is to develop cognitive models online, on the internet, or on your own sort of silo of you, and bridge communication between the mind through some sort of advanced BCI and the actual silo or the internet, and therefore share cognitive models between your online self and your actual physical self, and maybe extend the intelligence and extend the consciousness.
Certainly interesting. I'm very interested in BCI. So yeah, I think that would be really good.
Yeah, that would be interesting. I mean, maybe that could be an approach to recording and helping identify patterns within the mind that need to be recorded. I don't know. Yeah, food for thought. Yeah. So, I was going to say before, have you heard about the spider goats? Just as some, yeah.
No, I haven't. What is that?
Spider goats. Wow. Spider goat.
It's a spider. It's a goat.
Whatever spider goat does. So this is they've actually developed, or some scientists have developed a way to splice the gene of an orb spider into the fetus or the egg of a goat, and therefore produce offspring that can produce milk, goat milk, that actually has spiderweb filaments in it, and therefore farm spider silk.
Oh wow!
Because spiders are particularly hard to farm themselves.
So I'm guessing they only took the piece from the spider's genome that was responsible for producing this spider silk. So these goats don't have other spider-like features about them, like many eyes all over their body and
fangs and teeth. No,
8 legs, things like that.
There's some artistic representations of what went on out there on the internet, which are quite funny. But no, they look exactly like goats, except they produce milk that has the spider silk in the milk. And they think is useful because it's a very, very strong sort of substance, and you can use that for building, like making strong clothes, bulletproof
So what
jacket.
happens if you drink this milk? Do you become Spider-Man?
Maybe. There's a new Spider-Man movie coming out too. I wonder if they're going to include the Spider-Goat in it as a villain. A biotech experiment gone wrong. The evil Spider-Goat.
Okay.
This half Satan, half spider. What worse can what more horrible thing could you think of? So yeah, you've not heard of that? Oh well, I thought it was.
No, I haven't. No, but I'm not up on all my internet memes because I only spend a certain fraction of my time on Facebook, and
Yeah.
it's probably not enough.
Yes. Oh, it's probably
So much of
That's probably
it's dominated by,
so much
I guess, puns and comics and stuff about politics because it's all about what is Rick Santorum up to now. You know.
Yeah. I've only got a certain amount of time for thinking about those sorts of things, but I do find some of the pop science memes out there or articles that I come across quite interesting. So, yeah. All right. Well, yeah. Is there anything else you'd like to bring up about substrate-independent minds or recursive thinking that we haven't?
Not at this very moment, but there's a lot in the works, so I'm sure we'll have another opportunity to talk about that as soon as some of that comes out, and especially regarding the possibilities of whom to speak to in Australia. That's something I'm going to check out.
Definitely.
But I don't really have anything else I'd like to add at this moment, and I'm also, I should add that I'm tempted to finish this conversation in about 5 minutes because we have dinner coming up and I smell it.
Dinner.
So it's attracting me.
Wow, we've been speaking for nearly an hour though, so that's fair enough. And I've just had breakfast, so I'm lucky, and I've had a coffee and breakfast before, so I'm not feeling that hungry. But anyway, yeah, great talking again, and we'll do it again soon. And I'm looking forward to having you over for the Singularity Summit in Melbourne, which is in August, the 18th and 19th of August, part of National Science Week. So with Randal, we'll have Marcus Hutter as well, and possibly Colin Hales and James Newton Thomas and a few others. So we'll be revising the speaker list as the months draw on, and it'll be a lot of fun.
Is there a website? Is there a website for the Singularity Summit?
Yes, that's right. I've just it's just summit2012.singinst.org.au. That's summit2012.singinst.org.au. So if anyone wants to look that up, you'll find information about the summit there, and I encourage you all to come. Alright, so it's been great talking. Speak soon.
Yeah.
Cheers.
Okay. Thank you.